Welcome to Málaga and continuing YouTube coverage of the second Global Photonics Economic Forum. On October 7th and 8th, 2025, Optica gathered the world's most influential executives together. Here's the complete version of one of the 8 keynotes. Enjoy. Ladies and gentlemen, our opening keynote is from Jo De Boeck, Executive Vice President and Chief Strategy Officer at Imec, the world's leading independent R&D centre for nanoelectronics and photonics. Since joining in 1991, Jo has held key roles, including CTO, led the Smart Systems and Energy Division, and directed Imec's Holst Centre. He now drives Imec's global strategy. Today, Jo will share Imec's strategic vision, connecting semiconductor innovation, photonics, and European industrial sovereignty, and why Malaga matters. Imec's first R&D pilot line outside Leuven, Belgium, is at Málaga TechPark, backed by the Spanish and Andalusian governments. It will accelerate prototyping and multi-material semiconductor and photonics developments in healthcare, AR, and precision sensing. Imec Spain is currently hiring top engineers and leaders, building Málaga into a new innovation hub and strengthening Spain's role in high-tech. Please welcome Jo De Boeck.
Good morning. Wow, this is really a Global Economic Forum welcome here. Thank you, Jose. We feel very privileged to be here again on stage. Thank you also to the city and the regional governments for supporting us here, and of course the central government. You heard about our plans, and very welcomed here, and we feel at home. Like all of you, I'm sure, do in this second edition of the Global Photonics Economic Forum. So, is about applications, is about the need, is about driving impact into our future well-being and welfare. So I think that's what, of course, the focus of this conference will be. My role to open, of course, as a member of the research and technology community, is to make sure that we take one of those needs and drive from lab, from the innovation to impact those products, those services that are going to be important. And it has been said before in the beginning, AI, of course, is driving basically everything today. Of course, also it drives roadmaps that we are trying to fulfill with all of our innovations. And so with this, the challenges that AI poses, of course, besides, of course, the great opportunities, is energy. It has been noticed before, and I'd like to open here by just stating again what the infrastructure that is behind AI needs to do to make sure that we are not burning the planet while doing our AI applications. And so this all leads to energy efficiency. Energy efficiency, which is, of course, again, an innovative arena. It's a place where we need to bring our forces together. There are a few things that I'd like to mention in this roadmap. And first of all, we'd like to make sure that we can continue to push the envelope of compute. We all need more performance. We all need more transistors. Every transistor counts, has been said. And of course, jointly again, and this is a prime element of the discussion here and today and tomorrow, is which roadmap are we following? I show this not because of the details, but because of the fact that it's really forward-looking. We're looking at 2042 to enthuse our researchers, our PhD students, our professors, to focus on solutions we do not yet know how to bring to the community. And so, of course, this has been over many decades the case, but it's also how semiconductor looks at the world. And it has been said before, semiconductor technology will absorb the innovation that we bring in one or other format, and this is also what I'll show later on. The challenge of integration is there today, and also the vision of future products, future chips, if you want, is tremendous. We are looking at a functionality that needs compute, interconnect, memory, and all of these functionalities require different technologies. Bringing those together in a vision that in the future will be even more integrated than today is clearly what our research community today is looking at. These will pose tremendous challenges on precision, on combining all of these 3D stacked formats together, but also bringing in new materials and new opportunities. Chiplets are there to open the market, which are currently locked in maybe by big providers. It's a European opportunity as well to get into the game and to Schumpeter existing way of doing systems integration. And that's, of course, a very important element. The second one, of course, is the power challenge. By performance, again, we will burn more power. And although scaling will help to reduce the power use at the compute side, we will still, in global, use more energy. This is really important, and also there is the system technology co-optimization, a key word. We need to understand the types of workloads that will go into the system from the algorithms, and we now need also during runtime to manage this energy and energy efficiency. Many things to do there, many materials and again, device innovation is happening, spreading the heat, making sure that we have the sensors in the system and what the load is, and to also make sure that we have advanced power delivery systems. That was part of the roadmap already. We are actually looking at new ways to bring the power to the different layers in the current functional SoC. And then finally, the memory challenge. We all compute with data. Data needs to be very, very close to where the compute is happening because every transport of data consumes energy. And this is a key understanding. This is why we need photonics. This is why our community here will help to alleviate the problems. And again, it's going to be from cradle to product. It's going to be from this innovative idea with the many PhD students and professors and academia research that's ongoing, but then also accelerating this from the lab to the fab. And this is the key role that roadmaps play. This is also the key role of anyone and everyone who's pushing the envelope in bringing these products to market. And then knowing the playing field, and of course, this is a very technical slide. And again, I'd like to do justice to the technical details that my colleagues have brought to the presentation, but I'll surf over them to make sure that the message is clear. The message here being understanding your landscape. And it was said that, of course, electrical interconnect have been there for as long as all of us remember, but now photonics is creeping into this from the longer range, where fibers, of course, are ruling, also to interconnects that are at the centimeter level. The question only is, how do the systems integrators and architects make use of this? Standards will need to come in because everyone needs to know where this is going, but also technology and technology provision needs to be part of this game. And this is where, again, roadmaps come in. So I'll show in this landscape that I just showed at the previous slide a few key elements that we are developing together with our partners on trying to build, indeed, this roadmap going forward. And this is, for instance, on the data center interconnect area, standards, IEEE standards in forward reach and in data center reach, how data is being moved from one data center to the other or within one data center from one rack to the other. And so those standards drive the innovation in speed. It needs to go faster. And so it says a number of gigabits per lane. This means we are providing a certain amount of transport at the best energy efficiency. Again, the previous slide. So these standards, they actually force us to bring in new technology elements. Such technology elements can again be built in laboratories. At some point in time, they need to fit a platform that will be manufacturable, that can scale these innovations to the mass market that we all are envisaging. And this is indeed where semiconductor has great platforms. So one of the focus areas that we have brought as Imec to display is to make sure that we are using the quote-unquote standard, again, platforms to integrate photonic components and functionality. Try to be compatible as we can, or tailor a bit the compatibility if needed to make sure that these functionalities can be fit. Without, again, going into the technical details, this innovation now currently is on the market. You can actually design in, and the key word here is design. You can design your new components, your new systems using the process design kits for the experts in the room to actually start developing your own product. Not only developing it in the design arena, but also prototyping it and, when possible, scale in the partners that we have with the foundries that are in our ecosystem. The roadmap said that we need to go faster. That means that when we are going to, say, 400 gig per lane, that we need to implement, again, new functionalities. At the passive side, at actives, we need modulators. We need also detectors to be integrated on the platform. And we also need to look ahead at how the dimension, how to marry different technologies together, is going to be implemented in a foundry. This means a lot of complexity needs to be joined in again, and a lot of innovation is happening to push that envelope on faster and faster transmit. This is currently in play, but it's a lot of innovation that still needs to happen when we want to reach the 2030, 2032 type of standards and milestones. Again, here, for instance, in collaboration with our partners in Photon Delta and companies that are looking to push the envelope in integration, an example of the 3D integration using microtransfer printing. Microtransfer printing allows to bring different components manufactured in their own optimum technology to the stage of silicon. And so that allows us to actually complement the current existing silicon photonics on 200 millimeter and future 300 millimeter wafers to actually improve the functionality and make sure these new components can come in. Could be lasers, could be modulators, could be photodiodes, could be typical components that are actively helping the system to be integrated. Prime examples, and as a matter of fact, also presented at the ECOC last conference, is showing that there's something happening with the microphone as well, I think. The innovation is happening because we are looking into, and of course, these are currently still steps into the full scale, but we are actually integrating. This is a very nice result showing the thin film lithium niobate to actually provide at spec the functionality needed. So visit or revisit the paper if you want more technical details, but it's to show that these type of elements in close collaboration with academia and industry are really pushing the envelope forward. And it will continue in speed. It will, in some cases, need even faster access and pushing the data transmit at chip level, at board level. And so closing the gap towards the electrical interconnect and making sure the distances for photonic interconnect can become smaller in an energy efficient way. And therefore, again, we are introducing new components. You can see them on the screen here, different types of new breeds of elements that will be integrated, in this case now, in our 300 millimeter platform. Because also there you have the opportunity of bringing the 300 millimeter wafer strips, the whole integration effort that's there on 3D integration, you bring this to the photonics industry. So that's very important, and we see elements of through silicon via 3D interconnect, actually the opportunity to really densely interconnect the electrical components with the optical components. And that's where this connectivity will help, again, the energy efficiency for the systems. So we're driving this technology, and 3D integration is key for doing this particular type of functionality. 3D integration could be at microtransfer printing is one example. Another one, of course, and that will be very important for interposers becoming more active, like the active photonics interposers we're looking into in the near future. This will need active components like lasers to integrate it on the interposer. There, again, flip chip is a very interesting area, and we are, again, with our partners and Photon Delta to looking at showing this integration to happen today. So I think this type of integration is important. Actually, 39 years ago, I started my PhD on integrating gallium arsenide on silicon. Happy to see that today we have finally reached the quality to build gallium arsenide layers on silicon monolithically. So there's different ways, and I think that's the message, to approach the goal of combining functionality, optical and photonic functionality with the silicon platform. Like, for instance, here, combining the silicon germanium electro-absorption modulator, in this platform, in a monolithic version, and showing the key specifications that you need to do this component or to use this component in the future communication bandwidths. are very important elements. And again, without going into the technical details, and my colleagues are around to entertain you on those if you want to, the essence of the matter is, and this has been mentioned before, if you want to have impact, those results are fantastic, but you need to bring them in a community. You need to players that actually know how to understand, that understand how to bring this innovation to the platform, from the platform, aggregating the value chain from design to packaging and testing into the economic fabric. So we need the industry partners to pick it up. We need the VCs, we need the capital to pick it up, and we need to enable the companies that are in this race to scale. And there's many smaller companies, there'll be a few bigger ones. We need to understand how we can bring this value chain together. And so there, again, innovation is happening. Innovation not only at the area of AI, because we believe that the strength of photonics is evidently in other areas, as Jose pointed out earlier as well. AI is driving a lot of the market, a lot of the innovation, a lot of the absorption of photonics in the semiconductor industry, and we see platforms move. But for instance, some examples here on our own portfolio, for instance, on health, where we have seen that, for instance, genome sequencing has been driven integration of photonic components, by integration of photonics, of electronics, of imager systems. And so actually Pacific Biosciences in the early was a genome sequencing company that wanted to build on-chip what was at that time a very large optical setup. Photonics helped. We could integrate the strength of doing this type of sequencing on a silicon photonics type integration. That's very important. This type of innovation needs platforms, needs new fabs to do the lab to fab transition, and then needs the full ecosystem to deploy these innovations to market. Automotive, interesting example again, the car has eyes and ears. To complement the existing camera and radar, there will be LiDAR functionality, not only in cars, of course also in robotics, etc. Miniaturization of LiDAR is a key component. And here, proud to show the implementation today of a LiDAR system, again in collaboration with many of our partners and universities in the Photon Delta area as well, to look at this implementation and to demonstrate the functionality. We're not there yet. A lot of challenges still need to be covered on many different components of the LiDAR system, but we can show functionality. We can prove that further investment is going to be fruitful, is going to be paying off when you develop this component. Alternative compute, we talked about the AI type of compute and the data servers and centers today, but we are also looking with many of you in this audience to quantum compute, the next generation of compute. Not the chips that we use today, but the ones that will use the quantum principles to do unprecedented type of computing. Here, the jury is out on which technology will prevail. But to help demonstrate the capability and the potential of these technologies, many of us are helping. Photonics is key to bridge the quantum world with the real world. And their components that use the photonic integration technology will be key. We're developing new devices, new active devices, new filters, routing systems, beam steering equipment to help, again, show the potential of these different types of quantum computing in the future. We are really here, and actually physically soon here, to help accelerate that lab to fab transition. It requires roadmaps, it requires the ecosystem, it also requires the opportunity to do the functional scaling, to do going from concept all the way through initial prototyping and then hopefully scaled production. We need to build that ecosystem together. It does require a lot of investments in infrastructure, sometimes patience, but also a lot of energy and ambition. This is shared in the regions, shared in this country, shared within this room. We are very proud indeed to build out our existing facility under the CHIPS Act and the NanoIC pilot line, which will help to bridge this challenge to the next generation of silicon-based and CMOS-based devices. But to complement that with specialty components for which we fly over and help building the ecosystem here, which, as Jose said, the new version of what will become a fab that hopefully supports this and many other ecosystems in the future. With that, I hope I entertained a bit between the science and the technology, the way to get through roadmaps and collaboration to prototype and demonstration into, hopefully, a lot of impact in the economy. With that, thank you very much and wish you a very fruitful 2 days. Thanks.
Thank you very much, Joe, for a great presentation. Imec's story is about collaboration, about working together. So the first question comes from me. What can we do to help you? What can the people in front of you do to help to achieve those dreams of Imec?
Well, I think we share that dream, right? So it's not the Imec dream per se. It's, of course, a very dynamic environment to be in. Many of the people here, we met yesterday at the reception. Thank you. Very great organization. But also here during the coming days to build it together. Of course, we are connecting to the academic research community, but that, again, needs to be connected in the end to investments, startup companies, existing ecosystem players, and products.
We have some questions in the audience. At the back, please remind us your name and company.
It's Mike Powell from Renevo Capital. Could you talk a little bit about the tricky problem of fabulous technology at Imec, but at the moment in Europe, there's nothing really like TSMC, Global Foundries, Tower, etc. How does Europe go about getting such a facility onshore?
Thanks, Jose, for the first question, because typically that is the first question we get. It's a hard game, right? So, and on this stage, we will not have the solution. There's a few things that are happening globally. And one thing is, of course, we know that the ecosystem we have today is a global ecosystem. We all rely on each other. And I think this is the key message to make sure that we continue to rely on each other. Evidently, of course, with some stress in the world today, there is a key element of having a resilient supply chain. We truly believe that having the research done together is the best guarantee on a resilient supply chain later, because we build, again, the same roadmaps. We rely on each other to do the research and development, and henceforth, we build relationships that later on will also be relationships in business. Many of you know each other maybe from the PhD or study. Friends and partners in the economy today. So that's the first answer. Make sure you stay into this global collaboration. Secondly, also you have interdependencies. It's very important to double down on your strengths as a region to make sure that you are in the game, that you have interdependencies to share. Every good partnership is one where one partner is relying on the other for something, right? So that's a very important message, I think. This will connect us. And then, of course, in some cases, you need to have supply that is critical. We will talk about certain areas later today on stage as well, where this is clearly the case. So having a minimum fallback position on critical technologies is essential. So I don't have the solution for your question, but I think there's a lot of, well, I know for a fact, there's a lot of discussion ongoing. There was CHIPS Act 1, there was the investments here, for instance, in Spain, but in many other member states to make sure that you're part of the ecosystem. That's what we strongly believe in.
We have another question. Please remind us your name and company.
Hi, Dominic Solway from Light Trace Photonics. Thank you for the inspiring summary of Imec's ambitions and work so far. In your opinion, what are the major differences between scaling a CMOS technology versus an integrated photonics technology?
Well, you need certain components, evidently, that you cannot just harvest in a standard silicon platform. So there's a lot of effort in bringing these functionalities. I think one of the key messages of the presentation, and many of the ones following, I'm sure, is to make sure that we can marry these different functionalities. The big difference, of course, is silicon has been challenged before. I heard say earlier by, for instance, optical compute. It's been challenged before by many other ways of doing compute. It is a superpower. Why? We have been able to manage atomic precision at the scale of industry, which is unimaginable. Even after 40 years in the industry, it's hard to imagine that we place the atoms at the right pace and then carry this product in our pocket, right? So this is where photonics, of course, has a way to go in terms of precision, in terms of manufacturability, in terms of manufacturability, cost and adoption. But I think and one of the keywords was standards, we see it coming. So I think big challenges are that we need indeed to bring less big players to also see the benefit of using the silicon mainstream platform, but differentiate on top of it. I hope to, at least start answering your question. But it's an interesting debate to follow through in this community.
Yeah,
We
sure.
have another
Thank you.
question. Please remind us your name and your company.
So, Robert Harrison, an IP lawyer at Sonnenberg Harrison. We talk an awful lot about European sovereignty. We talk a lot about European resilience these days. How do we work together internationally with our partners in like-minded countries to enable European sovereignty? What does it mean for a company like Imec?
Well, I think first of all, and you're coming from the IP field, is to make sure that there is IP there's know-how, there's skills, as a matter of fact. There shouldn't be a presentation of mentioning the need of training. I think in that sense, we are supporting the sovereignty to make sure that we are building our talent. And again, a good reason to be here and in other places in Europe, but a lot of engineers are still grown. Also vocational study, quite important. So that's one thing to help support the goal of being less dependent. Sovereignty is a bit of a strange world in this very, very connected global ecosystem. So that's one way. We also, as I said earlier, connecting the bright minds early on in research makes sure that when they become decision makers, they know where to trust each other. And trust is the key word. So in the partnerships today, I see, and that's potentially true for many of you, some of these relationships go really for decades. So I think that's one important element. And then others, often decisions are made way above my pay grade, so I can't answer those. But I think we need to be vocal from our community also to the policy and policy makers that we are in need of collaboration. Otherwise, the pace will go down. And this will be then maybe in Europe or maybe in the US or other places. Let's keep the pace in all regions at the same height and make sure that we have our industry players, give them a level playing field to be in the battle, and then the rest is economy, right?
In a very nice discussion last night in Candado Beach in front of the sea, many of the people here were wondering, is there a roadmap to bring photonics closer to semiconductor activities? I had the honor of being on the scientific advisory board of Imec, and there we're having discussions on this. What is your preferred future? Should we have a roadmap altogether? Is Imec thinking of maybe showing the roadmap to others so we can all follow a similar direction?
Well, I don't believe in separate roadmaps too much. There's only one roadmap to success. Of course, bringing in the different technology options is the key where road mapping happens. Just for history's sake, the semiconductor road mapping has been since 70s, 80s, 90s very, very important and constant between the industry. Bringing together the industry like you do here is important to doing the same exercise, making sure that we as an industry understand where our technology is going jointly, and not competing competing potentially at the product level and the innovation level, but not competing on different views of the roadmap. So there's only one roadmap. I think that would be my message. And do combine them. Do combine the roadmap with semiconductor because it is a powerhouse.
You're going to be with us until Thursday. Lots of discussions to be had. Jo, thank you so much for being with us. Thank you.
Muchas gracias.
Thanks for watching this keynote. If you found it useful, please comment below, repost, subscribe to this channel, and save the date for next year when we return to Malaga at the same time as ECOP.